Today, in Geometry Review, we're going to solve for x using the Pythagorean theorem. This theorem states that when we sum the squares of each of the legs, that equals the square of the hypotenuse, like this. So, understanding that, I can tell that we have this major triangle, ABC. However, C is inside this major triangle. So I'm going to add another element here, or another letter. So now you can see that in reality, I have three triangles. So I have the main triangle, which is A, B, C. But then I also have the triangle formed by A, B, D, which is this little triangle here. And then I have another triangle which is formed by A, C, D. So as you can see, I have three triangles, as I mentioned. So working with the first triangle, triangle A, B, C, and I'll add the color just so that we can identify it, then we can say that the legs formed for this triangle are legs AB, or segment AB, and then segment AC. And then we have the hypotenuse, which is BC or CV, so the hypotenuse is BC. So from these three letters, remember these are my legs, this is my hypotenuse, then I can say that the segment AB squared plus the segment AC squared is going to be the same as the segment BC squared. Now, if you observe, the segment BC has 16 and 4. So I can tell that BC, or that segment, equals 4 plus 16. So that means that equals 20. So I can say that segment AB squared plus segment AC squared is going to be 20 squared. Then we're going to work with another triangle, the second triangle, which is ABD. So working with that triangle, let me put it right here, triangle ABD, which I will identify with this color. So that one, just like before, is telling me that segments BD, okay, segments BD and AD are the legs, and the segment AB is the hypotenuse. And how do I know that? Because between segments BD and AD, there's a 90-degree angle. So that means that the opposite of the 90-degree angle is the hypotenuse. So that's how I can verify that. So basically, based on that information, I know that segment BD equals 16 and that AD equals x. So I can say, notice that BD equals 16 and AD equals X. So my formula in this case would be BD squared plus AD squared equals AB squared. So replacing, I can say that is 16 squared plus X squared equals AB squared. So I can solve, so I can say that that's 256 plus X squared equals AB squared. Now I'll move to the last triangle, triangle ACD. With a 90-degree angle formed between the legs CD and AD. So let me write it down here. So my triangle ADC, which we'll identify with this color, has legs AD and DC with hypotenuse AC. As you can see here, hypotenuse AC, legs AD and CD. If I apply the Pythagorean theorem again, but before that, let's not forget that DC equals 4 and AD equals X. So DC equals 4 and AD equals X. So now, applying the Pythagorean theorem, I can say that DC squared plus AD squared equals AC squared. But DC is 4, so that means that I have 4 squared plus AD is X, X squared equals AC squared. So that means that my equation is 16 plus X squared equals AC squared. Now, I have the formula for AC squared equals 16 plus X squared, for AB squared equals 256 plus X squared, and then I have here AB squared plus AC squared equals 20. So that means that I can take these equations and replace them here. So my new equation will be 256 plus X squared, 256 plus X squared, okay, plus AC squared. So now it will be 16 plus X squared. And that will equal, we already had 20 squared, so now we know that it's 400. So we have AB squared here. So let's highlight it so that we can identify it properly. AB squared plus AD is C, so you can see where the formula came from, and that equals 400. So if I solve for this, I can summarize this to say, sorry, I can summarize it by saying that 256 plus 16 is 272 plus x squared plus x squared, that equals 2x squared, and that equals 400. Now, knowing that 272 is adding on this side, I can move it to the other side and subtract. So now I end up with the equation 2x squared equals 400 minus 272. That means that 2x squared equals 128. If my 2 is multiplying x squared, then I have to move it to the other side by dividing. So I can say now that x squared equals 64. So if x squared equals 64, then I can find what the value of x is by obtaining the square root of each term on either side. So the square root of x squared equals the square root of 64, which means now that the square root of x squared brings out x, and then what number multiplied together gives me 64 is 8. So x equals 8 is the correct answer. If I want to verify that I solved the equation correctly, I can simply plug back in my x into each of the individual equations. So I can say, for example, 4 squared plus 8 squared, that's the same as 16 plus 64, which equals 80. Okay, so AC squared equals 80. And then if I take 64 plus 256 from this equation, so I can say 256, which is 16 squared, plus 64, that gives me 320. And 320 would be AB squared. AB squared equals 320. If you remember, Pythagoras says that the sum of the squares equals the square of the hypotenuse. So this is squared, this already squared, so 80 plus 320 equals 400. This is true, so x equals 8. I hope you enjoyed this, and I'll see you in the next one.